Hello everyone. So yeah, I'm going to be talking about importance of shared mempool. Thanks to Yoav, he's already explained. I'm sure every one of us here, there are several account abstraction teams who have done the easy work since 2018 or 19, implementing a smart account in the centralized way. So, the initial part of my talk will have a lot of overlap with what Yoav has already covered. Given that we already had experience implementing account abstraction the easy way, we chose to tackle the difficulty right now with 4337, which is specifically ensuring we can handle the decentralization bit. So why first? We know, as you all covered, that with a centralized thing, there is a possibility of transactions not getting included for various reasons, which could be a faulty software, a faulty implementation, or your infrastructure being DDoSed, so transactions do not get propagated to the transaction mempool. Or there could be entities that could be actively or passively censoring you. Now, that's probably the reason why you need a decentralized version of the account abstraction infrastructure. So just to give you a progress of what happened or when we started off, we started the decentralization or the P2P interface of this back in January 2023, where we had the kickoff. The P2P spec, the initial version of that was ready in February 2023. We had the first implementation POC back in March 2023, and other teams implemented the initial version of the spec, and we had a version of a multi-client bundler setup running by September 2023. And then based on our experiences that we gained during this initial testing phase, the P2P spec was revised. We identified certain areas where we could improve, and a new version of the spec was released back in December 2023. And I can confirm today, we have a running mempool on Sepolia, a user of mempool on Sepolia, supported by 3 bundlers, Skanda, Silius, and Voltaire. All of them support entry point 6 at the moment. Soon we'll be supporting entry point 7. Alchemy's bundler support for entry point 7 is also expected quite soon. So let me talk more about what the P2P interface is. It was inspired by Ethereum consensus spec. It has 3 main domains. We use diskv file like Ethereum, the consensus clients. And then you have the gossip subdomain, which is used primarily to propagate user operations that is received by one bundler to all connected peers. Now, something that you'd have to make a note here is that the global topic that gossip sub uses is something known as a mempool ID. And what this mempool ID is essentially an IPFS hash of a YAML file. And the YAML basically describes what entry point contract is being used, on what chain ID it is that you generated that particular mempool ID for, and a few other information like what is the minimum stake required, etc. The ERCC 4337 team maintains a list of canonical mempools for each chain at the moment, and you can find this list in ETH Infinitism GitHub repo, and each of these YAML files will also be pinned on IPFS. All bundler implementations would support the canonical mempool. By canonical, I mean the pools that support all the rules specified in ERC 4337 spec. And you can find a list. Anybody is free to publish their own alt mempool as such, with any exceptions they wish to do so. But if you want other bundlers to participate in that, it's good if you were to, say, submit a PR in the ETH Infinitism repo, as well as pin your YAML file on IPFS. And once the particular mempool ID is known to other bundlers, they can start participating in that alt mempool as well. The third domain that you see is the request response. This, again, quite similar to the execution as well as consensus layer clients. You have a different thing for exchanging status of connected peers, obtained metadata associated to individual bundlers. Again, these are tailor-made for bundlers, so there'll be slight differences from how consensus clients behave, but the ENR for bundlers again is slightly different. It's not exactly matching to what the consensus clients do. And then you got the pool user op hashes. This particular one is probably, so for example, you consider you have a mempool that's already live with several bundlers talking to each other. You decide to spin up a new bundler. So how do you populate or seed your mempool immediately, your local mempool? You reach out your connected peers and ask them to send over the list of user op hashes that reside in their local mempool. For that, you use the pool user op hashes. You would get a blob of, sorry, a wrong word. You get an array of user op hashes, and then you can decide to get further information about that hash by requesting pool user op by hash. And goodbye is another request response domain which is used to probably exit from a particular, or you want to disconnect from a peer because you find it to have been sending you spam. You could call the goodbye and then exit the pool. So these are general information that is available in bundlers. So while implementing, what are the challenges that you see, especially when you're dealing with a P2P interface? You have covered most of them. The main challenge that we've witnessed, especially on quicker chains or like Polygon or L2s, is that you have a scenario where when, now consider a scenario and a user, what do you say, submits user ops, 4 different user ops to a bundler. And that bundler propagates all of them to its connected peers. Now say bundler A propagates all 4 to bundler B. And at the same time, bundler A decides to bundle 2 of these user ops. And bundler B, unfortunately, decides to say there's a partial overlap in the bundle of bundler B as well. And both of them relay these information to the blockchain. Now, one of these might revert on chain because there is an overlap of one of the user operations. And this would result in grieving the bundler. The bundler will not get paid if there is an on-chain revert. Now, how do you solve this problem? And given that this problem is more prevalent in L2s or Polygon and other alt elements, one solution for this is the chains have to implement a conditional endpoint called send raw transaction conditional. This has been implemented in Arbitrum. We are hoping and speaking to various other L2s and Polygon to insist that they include this in the sequencer, because it's been live on Arbitrum for close to a year now without any issues. So we are hoping that other L2s and alt L1s could implement them. This is essential before we could launch the P2P interface on these chains. The second, as I've explained, the second challenge is like any other scenario where you could be front run as a result of what you suit. Now, when you're using a user op mempool, searchers or malicious bots who look to extract MEV have that, what do you say, an additional advantage because the user op is still not included on chain. So they would be able to sniff for profitable MEV in the user op that's being generated and could front run you in a better, front run you, and you end up losing. So what is the, how do you solve this scenario? Bundlers would essentially function as builders. So bundlers, wherever there's a builder API available, will leverage the builder API and submit these user operations or bundles that they would generate through these builder API. And at the moment, builder APIs are predominantly available on Ethereum mainnet. So every bundler implementation in a way leverages this builder API, Flashbot's builder API to submit transactions. On alt L2s, or at a bare minimum, what you have to do is probably use the Flashbot's protect endpoint. But just to give a caveat, these so-called protect endpoints do not work on any of the L2s or alt L1s. So much so that we were front run only after using a so-called protect endpoint. And there's a lot of misleading marketing around these protect endpoints, and deep down in the documentation, they would say that they cannot guarantee protection on, say, a Polygon or any other network. So please be aware that before you decide to choose any of these protection strategies. Hopefully, sometime in the near future, we might, there are several other projects coming up with encrypted mempool, which might be available on L2s and other L1s, and we would be able to leverage them for MEV protection. Now, how could you become or join the P2P network? You could use one of the 4 bundlers that I've listed here: Skanda, Silius, Voltaire, and Rundler coming soon. And once you use these bundlers, in order to connect to the mempool that's live on Cephalonia, you would have to connect to the ENR that's listed here. This information would also be available on the Infinitism website. Etherspot are running the boot node for Cephalonia. We would be doing so for other chains as well once we join. And once you connect to this boot node, you would be able to join the network. I'd like to acknowledge and give a shout out to all individuals and teams who have been involved in making this thing possible. Obviously, Yoav, Dror, and Shahaf from the ERC 4337 team, Dan Coombs from Alchemy, who helped and critiqued a lot on the spec, Sharif and Mark from Candid, who were also commented on the spec and helped in building the Voltaire bundler, Vid and Will, who worked on the Silius bundler, and Utkir and Arjun from Etherspot team, who also worked for the Etherspot bundler. What's the road ahead? So, as I said, we already have the mempool live on Cephalonia right now. Next week, starting from next week, we'll be doing some fuzz testing, and we are hoping to launch on Ethereum mainnet and Arbitrum mainnet tentatively towards the end of April. On Polygon, we are still working with few teams. As I said, the send draw transaction conditional is still not part of the Polygon sequencer. We are working with teams to make this available or looking at other options so that bundlers don't get grieved when they join the mempool. And it's imperative for us. We understand Polygon is the most popular chain for ERC-43 bundles at the moment. And we understand that we should make this available on Polygon to make it more decentralized. Optimism and Base, again, we are in touch with the account abstraction teams there. They understand the problem or the issue that would arise because of on-chain reverts if there is overlap of bundles, and hopefully we should have this inclusion of this endpoint at the bare minimum quite soon. And we are talking to other L2s, and we would like to seek help of any team who are working in account abstraction space. If you do have any contacts with other L2s, please encourage them to include these new conditional transaction endpoint. It will help us decentralize the network, thereby benefiting everyone. Right. In conclusion, what could you do as a dApp? Use a bundler that is compliant with 4337 specs. There would be new spec tests that would be upgraded to include specific test suites that are compatible with the P2P interface. If you're an L1 or L2, please add support for the raw transaction conditional. As you know, this is an essential endpoint that would prevent bundlers from being grieved. And as an end user, please use dApps that leverage the shared mempool. All right. Thank you.